7 is translating functions review. And the directions say to translate each function into the specified form. So if you have a table, you can turn it into an ordered pair, which is called a relation, an equation, a graph, and also a word problem. So let's look at number 1. Translate the relation, and it's giving you the ordered pairs, into a table. So we're going to put them into the table that's already been given to us. And we have x and y for all of them. So we have 4 and 3 is our x and y. -2, -1. 6, 3. 8, -12. So that's how we would change a relation into a table. Question number 2 says to translate the function f of x equals 4x plus 1 into a relation. So we have the function, which is going to be the equation, and we need to turn it into a relation, which is a set of ordered pairs. So I'm going to put some parentheses over here to remind myself that I have to change this, it's not going to be a table, it's going to be ordered pairs, because that's what a relation is. I have my function table, and I'm going to put in the middle the 4x plus 1. Because that's the equation I'm going to substitute everything into. Then I get to choose the ordered pairs or the x values that I want to use, because that's the independent value. So I'm going to choose -1, 0, 1, and 2. And you can choose any numbers you would like. As long as you do it correctly, you'll be okay. Now that I have my x value, I'm going to substitute it in to the x in the equation. So 4 times -1, because that's what our x value is, plus 1. Now I'm going to solve it. 4 times -1 is -4, plus 1, and that's going to give us our y value. -4 plus 1 is -3. Let's substitute the 0 in. 4 times 0 plus 1 equals 0 plus 1, which equals 1. Now let's substitute the 1. 4 times 1 plus 1. 4 times 1 is 4, plus 1 is 5. And then the last one that we've chosen is 2. 4 times 2 plus 1. 4 times 2 is 8, plus 1 is 9. So we've now changed our function into a table, but our actual problem says to change it to a relation, which is the ordered pairs. So we have our parentheses set up. We're going to simply take our ordered pairs and plug them in. And remember, our ordered pairs is x and y value. Our second one is 0, 1. Then we have 1, 5. And 2, 9. Now let's look at question 3. Question 3 says to change the relation, which is the ordered pairs, from ordered pairs to a graph. So to do that, we're simply going to plot the ordered pairs. The first one is -3, 2, and remember, it's always x and y. So I'm going to plot the first one, -3, 2. So -3, and then I have to go up to 1, 2. There's the first ordered pair. The next one is 1, 1, 1, and then 1. -4, -3, -4, -3, and then -2, -2, -2, -2. And that should be what it looks like. Number 4, translate the graph into a table. Now we're going to go the reverse direction. We're going to look at the points that are on the graph. and change them into the table. So I'm going to start down here just because I like to go from left to right. And that's going to be -2, -4. And then the next one is right here. That is -1, -2. And then 0, 0. And then 1, 2. And that's all I really need, but if I wanted to do that last one right here, I would do 2, 4. And the last one is question 5. We're going to translate the function. So we have the equation, and we're going to turn it into a table, which we've already done before. So I'm going to now start by putting the equation into the equation box in my function table. 3 minus x. And I'm going to stick with the numbers I chose before because you can choose whatever x values you want. I'm going to choose -1, 0, 1, and 2. Now I can substitute the numbers in. And this -1 that we're starting with is going to be a little bit tricky because of this minus sign. So we have 3 minus, and then I'm going to put in the -1. And we know that 2 negatives make a positive. So we have 3 plus 1, which equals 4. And then 3 minus 0, which of course equals 3. And then 3 minus 1, which is 2. And then 3 minus 2, which is 1. And because it's asking for a table, we are finished.